Hi, all, it's Mr. Yeager for chemistry. We are now looking at pH calculations in the acid and base unit. Again, another teacher made this wonderful presentation, and this is going to be the big math section of it. So we do follow up with one more bit of math when we do titrations, but we'll get to that on another video. All right, so pH. So for pH, we have some formulas. Again, we talked about the pH scale. It is an acid scale. It is telling us how strong the acid is. If the pH is lower, it's even stronger, which I know kind of seems weird. All right. So the lower the pH, the more acidic the compound is. And then the higher it is, the more basic it is, the more that it's a base. Again, less than 7 is considered an acid, greater than 7 is a base. But the pH scale basically is telling you how acidic it is. A couple things. This H3O plus we're about to see quite a bit. This is known as the hydronium ion. Okay? The hydronium ion. That is, again, the acid ion. You will either see this written as H3O plus. If we just write H plus, it's the same idea. H3O plus is H2O with the additional H plus on it. That acid ion has been donated to it. Okay? So that is the hydronium ion when you start reading that in some of the problems. We already know OH minus is called hydroxide, so hopefully we're not getting those two mixed up. Okay? Now, there is something called the pOH scale. The pOH scale is actually the base scale. Okay? So it's the opposite of the pH scale. And so if you have a low pOH, you actually have a lot of OH minus, which means it's a base and it's stronger as a base. So it does depend on which way you are looking or which scale you are looking at. They are opposite scales of each other. From there, let's look at the different formulas. And again, you'll be given these formulas. You just got to be able to use them. We have pH is equal to negative log of the concentration of H3O plus, the hydronium, the hydrogen, the acid concentration. All right? So this is something, there's really not a lot of work for you to show on these problems. You just got to be able to plug the number in correctly, because you will have some scientific notation with this as well. So you got to be good about how you are plugging it in. But you just use negative log, and I know you might be like, oh my gosh, logs, I don't know much about logs. You don't need to know a lot about logs. Just plug it on in, negative, hit the log button, type in the concentration. If you want to find the concentration and you're given the pH, you type it in and it's 10 and to the exponent negative pH, and then you hit enter. And that'll give you the concentration of H3O plus, which we should be putting into scientific notation. On the other side, basically the same idea with the pOH scale. The pOH is a negative log OH minus, and then if I want to find the OH minus, I do 10 to the negative pOH. All right? So it is a logarithmic formula, and the whole point of a log is to make a really small or really large number something much less easy to understand, and it's all based on a base 10 unit. Okay, at least in this one that we're doing. We do then have one other formula that's very simple. If you add up the pH and the pOH, it always comes out to 14. So that's something else to understand as well. Okay, so that's what we are using here, and we'll go from there. Okay. All right, so it says, what is the pH of the solution with the hydronium concentration of 2.5 times 10 to the negative second molar? So guys, there's really not a lot to do with this. You just go, pH equals negative log of 2.5 times 10 to the negative second. And you type that in. Negative log, I'm doing it right now if I can find my log button, there we go, 2.5 times 10 to the negative 2. And it comes out, we'll do sig figs based on just the digits in front of the scientific notation. This is 1.6. So pH equals 1.6. Now one thing that I do like to do with this is I then go, okay, you found the pH to be 1.6. Is this acid? Is this base? or is this neutral? Well, the pH is less than 7, so it's acid. Done. Okay, so we do often do that as well and go identify whether the solution is acidic, basic, or neutral. All right, next one. What is the pH? I mean, again, there's not a lot to do with these if you could just plug it into the formula. You're given the hydronium, that's the H3O plus in brackets. So plug it on in. Negative log of 7.4 times 10 to the negative 6. And that would be 2 sig figs, 5.1. So this would also be acid, right? Less than 7. All right. I'll do one more. We'll try to do, I guess, 3 examples in each one. All right, what is the pH of this one? You're getting the idea. Negative log of 9.11 times 10 to the negative 11th. This one would have had 3 sig figs. Oh, I screwed something up there. Oh, I'm sorry. Negative log, I was too fast. Negative 0.11 times 10 to the negative 11. There we go. Apologies. This comes out to a pH of 10.0. So this one's actually a base because it's greater than 7. All right. There we go. I guess we are doing 3 examples for each. All right. What if now it's saying I want to calculate the H3O plus? So my formula for this is H3O plus is equal to 10 to the negative pH power. So I would type in for this one, it says the pH of the solution is determined to be 12. Right there, the pH is 12. So you already know that this is a base. But we're calculating out the hydronium, so I'm just doing 10 to the negative 12. Now, and I get 1 point, and I do actually need 3 sig figs, so 1.00 times 10 to the negative 12 molarity. You are getting concentrations from this. Okay, it says that, find the concentration. All right, you do need to have these in scientific notation. I'm just going to be clear about that. You're not going to write 0.0000 11 times and then 100. You do need to be in scientific notation. If you want to change your calculator over to scientific notation, do that so that it gives you the answer right away. Okay, so we'll see it with this one, for example. It says, what's the pH if the solution is 3.67? So I already know this is acid, if that's one of the things you have to get. I would do 10 to the negative 3.67. All right, so this is what I'm talking about. If you're not in scientific notation, you're going to get 0.000213796. I'm not going to accept that on the test. I'll be like, nope, I'm not taking that. We need to put it in scientific notation. So this would be, again, you either remember how to do it, because we've gone through it a couple times now. Moving the decimal point over, you're moving it 1, 2, 3, 4 times, 2 point, and I need 3 sig figs, 1, 4, times 10 to the, and I moved it over 4, negative 4, because it's a small number. The exponents will all be negative, if that helps you out at all. Okay, we should not be getting positive exponent numbers on these. All right, another one, 10 to the negative 8.279. This is going to be base because I'm above 7. 4 sig figs on this one. Oop, this is where scientific notation comes in play because you're going to have issues with this. This comes into 5.260 times 10 to the negative 9th molar. Okay? So I would recommend that you do change your calculator over to scientific notation mode. I know it might be annoying that you're going back and forth, but maybe on a test you solve all of the ones that you're putting them into scientific notation and then change your calculator back and make sure that you're not doing everything in scientific notation. All right, calculating pOH. I'm not going to do a lot of these this time because it's the same idea, okay? The only difference is I'm now looking at hydroxide. I do have the hydroxide calculation and it says solve for pOH. So again, pOH would equal negative log of the OH minus. So I would do negative log of 0.0486 and I get 1.31. I never said it. There are no units for pH and pOH, if you didn't notice me not putting any units down on those first couple problems. So it's either no units or molarity. But 1.31 would be your answer. Now, this is where you can get a little confused, and you got to be careful. This is pOH. When you're less than 7 on the pOH scale, that is base. It's the opposite of the acid scale. One more. What is the pOH of this? So this would be negative log of 8.32 times 10 to the negative third. I'm getting 2.08, no units, less than 7, this is base. Okay, I know there's one more, but we're going to skip that one. What about calculating OH minus from pOH? Same thing as going to H plus. We're doing OH minus concentration is equal to 10 to the negative pOH. So 10 to the negative 2.93. And I'm getting 1.17 times 10 to the negative third molar. All right, there's not a lot to show. I mean, you got to just be able to go, I'm going to figure out the formula to use, and that's really the only thing here, and we're going to get to some ones where we're starting to use both a little bit. But you just got to read and be like, okay, I'm asking for hydroxide, I'm looking at pOH. And you go back to the formulas and go, do I have a formula that has hydroxide and pOH in the same formula? And then you use it, okay? So the last one with this, it would be 10 to the negative 12.93. That is 1.175 times 10 to the negative 13th molar. The pOH is greater than 7, which means this is an acid. Okay, there's not a lot of hydroxide, there's going to be more acid in it. Okay, skipping that one. All right, so what we're getting to now, it says calculate pH from OH minus. So this is what I was talking about just a moment ago. You have basically these formulas. I'm not going to be able to keep writing them up over and over again. Let's do it this way. You have these formulas. pH equals negative log of H3O plus. We said H3O plus is equal to 10 to the negative pH. We have pOH is equal to negative log of OH minus. And we have OH minus is equal to 10 to the negative pOH. And then we have this last formula, pH plus pOH equals 14. All right, so I can see people getting confused and going, oh, these are so difficult, okay? It's really not. You can see that there's like no work to them, okay? But you can obviously pick the wrong formula and then it's immediately wrong and you're losing all these points for it. What we basically have done so far is we've only done problems where you've been given you've been given something and the same, and what you're looking for is all in one formula. So we started with H3O plus, solving for pH. So because I have this formula, I'm just plugging it into the formula. Then I gave you pH and I said solve for H3O plus, so we use this formula. Then we use this formula, then we use this formula. Okay? So if what you're given and what you're going to is in the same formula, use that formula and plug it on in. What we're about to do now is in the problems we're being given here, it's giving us something that we don't have the solution in one formula. In this, it's telling us the OH minus concentration, 2.0 times 10 to the negative 8, and it says solve for pH. Well, I don't have a formula. Look, I have this formula. Again, I'm drawing it right next to it. That has OH minus, but that's only going to give me the pOH. or I mean vice versa. I mean, I have this formula and I have this formula that has OH minus concentration in it. I have nothing that has OH minus concentration and pH in the same thing. I don't. So what do I need to do? This is going to be a two-step problem. My suggestion and what we're trying to lead you toward is that we use this formula that I'm starting now again, the pOH formula, first. You change the OH minus to pOH, and our goal is to get down to this bottom easy formula of pH plus pOH equals 14. That is the easiest formula up here, okay? Because all we're going to do is subtract from 14, all right? So that's what we're working on here. So I have to rewrite this. So what I'm saying is we're going to calculate pOH first. pOH is equal to negative log of 2.0 times 10 to the negative 8. I'm not getting my final answer. I can't get my final answer in one step. There's no way, and there's no way to combine them. So negative log of 2 times 10 to the negative 8, I get a pOH is equal to 7.7. Okay? But that's not my final answer. But now I can do pH plus pOH equals 14. pH plus 7.7 equals 14. Subtract the 7.7 to the other side. pH is equal to 6.3. Done. Is this acid or base? It's acid. Okay? So that's what we're going to be doing here. We're taking our time, kind of converting. Now again, we're being nice and kind of doing the same thing over and over again. I'm going from hydroxide, change hydroxide concentration into pOH, and then change pOH into pH. So negative log of 6.50 times 10 to the negative third equals 2.19, and then pH plus 2.19 equals 14. pH is equal to 11.8. We're going to have to go with on this one. Okay? 11.8. All right? And this would be base. Got it? I'm not going to do that one. Let's calculate OH minus from pH. All right, playing around with this. So in this one now, I'm starting with pH. I want to get to OH minus. Well, what am I going to do? I'm going to start with my easy formula, pH plus pOH to 14, get the pOH, and then plug it into the second hydroxide formula. Okay? So I'm going to change pH into pOH and then change it into OH minus. So I start with 10.65 plus pOH equals 14. pOH will equal, this one we don't get rid of any sig figs. 14's not, we don't worry about the sig figs for 14. 3.35. We also already know that this is a base because the pH is so high, and that's confirmed with the low pOH. Then I do 10 to the negative 3.35 will equal to OH minus, which equals 4.47 times 10 to the negative fourth molar. Okay? I'm going to skip anymore. Let's go with this one. Calculate pOH from H3O plus. This one I'm going to start with H3O plus. What am I going to change to first? I'm going to change this into pH. And then I'm going to change it into pOH. You're getting the idea. All right? If I'm in H plus and I'm going to pH, it's one step. If I'm in OH minus and I'm going to pOH, it's one step. If I'm trying to go from OH to H or H3O, whatever, it's going to be two steps, and I'm going to use that 14 formula, the pH plus pOH, at least either at the beginning or at the end of the problem. If I'm starting with concentration, I need to turn it into it first. So negative log of 8.63 times 10 to the negative 10th. That is giving me 9.06. So this is a base, because that's my pH. And then 9.06 plus pOH equals 14. pOH will equal 4.94. All right, that's it. There's obviously more examples here. I'll do this last one because I haven't done this section, where I'm going from pOH back to hydronium. I'm going to go pOH to pH to hydronium concentration. So I'm going to do pH plus 3.0 equals 14. That one I can do in my head. That would be pH is equal to 11. And then I do 10 to the negative 11th, which is going to be 1.0 times 10 to the negative 11th molar. This isn't that. This is a base because of high pH. And that's it. Okay? So, take your time. Don't get too intimidated by these formulas. Again, see what you're starting with, see what you're going to. It's either going to be one step or 2 steps to get there. Anything more, you're making a mistake. All right, well, very good. That's it.